In this short video, we're going to solve the practice problem, the problem of the day for November 26th that I posted on the website. So the first part of the question is pretty long, and I'm looking at it, it's two separate paragraphs, so that's really not going to work for me. So I'm going to cross this out and mentally split it into two parts. We'll do the first paragraph and then the second paragraph. So the first paragraph says that Steve earns $200 a week from his job, and he uses the money to buy medicine and to self-medicate. The price of the medicine in the pills is $10, and the price of shots is $20 a shot. And then we're asked to draw a well-labeled diagram with typical bowed in towards the origin and difference curves that illustrates the budget constraint at his optimal choice of 5 shots and 10 pills. So let's break this down. First, we're going to need to start, and since we need a well-labeled diagram, we're going to need to put in the labels. So we'll do pills up here, and conveniently that's the unit. The pills are measured in pills, and then shots over here. The shots are also measured in shots, so that's nice. And now we're going to fill in the budget constraint first. Typically, it's a lot easier to start with the budget constraint. So we know that pills cost $10. That means he can afford 20 pills total if he spends all of his income. So we know this point that I've just labeled is 1 point on the budget constraint. And we know that he could afford 10 shots if he spent all his money on shots, because 200 divided by 20 is 10. So you have a second point on the budget constraint, and now we know the budget constraint's a straight line, since the slope is equal to these prices, and these prices haven't changed. They don't change at any point. So now we have our budget constraint, and then the last thing it asks us to do is use a typical bowed in towards the origin and difference curve to illustrate an optimal choice of 5 shots and 10 pills. So we're going to want this 10 pills and this 5 shots. We'll put dotted lines up and across to see that this is going to need to be our optimal choice. The condition for our optimal choice from lecture was MRS, that's the slope of the indifference curve, equals price ratio, that's the slope of the budget constraint. So at that point, we're going to need to have our indifference curve tangent to the budget constraint. Tangent meaning the slopes are the same. And graphically, that looks like this. So now we have our budget constraint drawn in, we have our indifference curve, we have everything labeled, including the prices. We might want to label this optimum, just in case the grader is a nitpicking dick. But it looks pretty good to me. And we can move on to the second part of Part A. So now we're asked to verify that Steve spends all of his income by calculating, and then to explain how the diagram illustrates that Steve is spending all of his income. So we have to break this into two parts. The first part, we can calculate how much Steve spent by calculating how much he spent on pills and how much he spent on shots, and add them up. And hopefully it will come out to be 200. So you know the price of pills is 10, and he bought 10 pills. So this is spending on pills. And we also know that the price of shots was 20, and he bought 5 shots, so this is dollars spent on booze. And sure enough, 10 times 10 is 100, plus 20 times 5 is 100. This adds up to $200. So Steve did spend his entire $200 a week income. Now we have to explain how the diagram illustrates this. The key point is that the optimal bundle, the one that we highlighted on the graph before, is on the budget constraint. You can elaborate on that. It's good to do a brain dump on tests, to throw in some vocabulary, for instance, to define terms like optimal choice and budget constraint. But ultimately, graphically, all we really needed to see was that the choice was on that budget constraint. It was at the frontier of the budget set to prove this point. Part B is even longer than Part A, so that's really not going to work for me. I'm going to cross this out and break it up into 2 parts at least. So in the first part it says Steve gets married and his wife Tian Tian gives him a $100 a week spending allowance for being good and washing dishes and managing her 401k. This is pretty realistic. Note how the family illustrates gains from specialization. That's just unimportant random information to throw you off track. On the same well-labeled diagram from Part A, illustrate Steve's new budget constraint and new optimal choice of 12 shots, and 6 pills. So the income went up to $300, so we know our budget constraint should shift outward and up and to the right. So with an income of $300 and a price of pills of $10 per pill, we know that the maximum number of pills that he could buy is 30. We'll label that point. And with shots costing $20 and an income of $300, he could buy 15 shots. So we have our 2 points just like before. And we connect the dots using a straight line. And then again, just as before, we're going to need to find the 2 points. We're given 2 points that we know are the optimal choice. It's 12 shots. So that's about right here. And 6 pills down here. And we know this point here is the optimal choice. So we know the indifference curve is going to have to be tangent to the budget line at that point. And now we've illustrated everything they've asked us to illustrate on this same well-labeled graph from before, so we can move on. Determine whether pills are normal or inferior and whether shots are normal or inferior. And then there's a bunch of garbage that's just meant to distract you. So let's first focus on pills. How can we determine if they're normal or inferior? Well, they're normal if we consumed more of them when the price went up. When income went up. They're inferior if we bought fewer pills when income went up. On our graph on the previous slide, we saw that the consumption of pills declined from 10 to 6, so it's got to be inferior. On the test, you should do a brain dump explaining what inferior means and your process for how you read that off the diagram. Shots, we know consumption increased substantially from 5 to 12, so we know that shots are normal good. Does this make any economic sense? Well, maybe when we have more money, then we're less sick, less depressed, so I take fewer pills. And then, like any good college student, I'm going to spend most of my extra money drinking. So I think this example makes a lot of economic sense. For this problem, we're told that Maya Walsh, the new mayor of Boston, is a recovering alcoholic. And as a man who enjoys his shots, he passes a law ending the ban on happy hour in Boston. This reduces the price of shots by half. On a new graph, illustrate how this change in price will influence Steve's choice of shots and pills. Now, while it doesn't say this, we know that since the prices are changing, the budget constraint is going to change. So there's going to be points on this question handed out for drawing the budget constraint correctly, and drawing in an appropriate indifference curve, and for analyzing the graph and labeling it. So we know that there's a lot of things we need to pay attention to as we draw this graph. First, we need to get the labels right. So these are shots, the units are shots, these are pills, the units are pills. We know that nothing changed as far as pills go. We have $300, like in Part B, and a price of $10 per pill, so we can buy 30 pills if we spent all of our money on pills. Now we know that the price of shots dropped by half. That means that shots are now only $10 each. So we know that we can buy 30 shots if we spend all of our money on shots. So now we can draw on our new budget constraint. And since it says that we want to illustrate the change, illustrate how this influences Steve's choice, they're really asking about how my choice will change. So we should probably draw on the old budget constraint, which was here at 15. This point was on the budget constraint, and the other point was also on the budget constraint. And then we had an optimal choice of 12 and 6. So now we can illustrate how things changed relative to this initial point. We know that from the previous question, shots are a normal good, so this lowering of price will have a positive income effect. We also know that the substitution effect is always positive when the price is lowered, so we know that our graph should illustrate an increase in consumption of shots. Furthermore, we know that pills are an inferior good, so the income effect from pills should be on pills should be negative. So you should have fewer than 6 pills and more than 12 shots. A point consistent with that is out here. We can say that that's 5 pills and 25 shots. So now we have our well-labeled diagram, and we're left with one last question. Are shots a Giffen good? This is sort of a trick question because we know from lecture that Giffen goods are really strongly inferior goods. Strongly inferior enough where the income effect can dominate the substitution effect. But we've already established that shots are a normal good. So that was just a sort of trick question. The answer is no, because it's normal. And that wraps up the entire question. Hopefully this process took you about 20 minutes, because I think this is a solid Blue Book question, maybe a little bit shorter than a typical Blue Book question, so you'd have about 20 minutes to work this out on the test. Thanks for watching.